Welcome. In the early universe, something fascinating was happening. Time seemed to move in slow motion. Scientists observed this period when the universe was about 1 billion years old and discovered that things were happening at a much slower pace compared to the present. This finding supports Albert Einstein's general theory of relativity, which suggests that the distant universe moved much more slowly in the past. Studying the early universe is like looking back in time, given the immense size of the cosmos. The faint light from the oldest galaxies is still traveling through the universe to reach us, which means that the most distant points that scientists can observe are actually a glimpse into the past. However, investigating the ancient universe, formed by the Big Bang approximately 13.8 billion years ago, is an incredibly challenging task. The reach of sophisticated telescopes, observing in different wavelengths of light, can only extend so far into the cosmos. Therefore, scientists turn to a phenomenon that can serve as a kind of cosmic clock: quasars. Quasars are supermassive hyperactive black holes located at the center of primitive galaxies. They are so bright that they outshine our own Milky Way galaxy by a factor of 100. This luminosity acts as a cosmic clock that researchers can use to track time in the universe. By observing quasars over time, a team of astronomers was able to perceive how the universe appeared to accelerate as it aged. The results of this research were published in the journal Nature Astronomy. Looking back to a time when the universe was just over 1 billion years old, we realized that time seemed to flow 5 times slower, said Geraint Lewis. If we were there, in that infant universe, 1 second would seem like 1 second, but from our position over 12 billion years into the future, that initial time seems to drag. This research reveals that the universe is expanding, and the rate of expansion is accelerating, something that scientists are still trying to understand. Unraveling what happened in the early universe can help scientists unlock the greatest mysteries about its origin, evolution, and what the future holds. Thanks to Einstein, we know that time and space are interconnected and that since the beginning of time, with the singularity of the Big Bang, the universe has been expanding, explained Lewis. This expansion of space means that our observations of the primordial universe should appear much slower than the current flow of time. In this article, we demonstrate that this is the case until about 1 billion years after the Big Bang. Quasars were analyzed by co-author Brendan Brewer, a professor of statistics and astrostatistics at the University of Auckland, New Zealand, over the course of 2 decades. The observations, made in different wavelengths of light, seem to tick-tock like clocks. Astronomers also use supernovas, which are massive star explosions, as another way to measure the universe's slow-motion passage of time until about halfway through its current age. While supernovas act as a single burst of light, making them easier to study, quasars are more complex, like a continuous fireworks display, noted Lewis. What we did was unravel this fireworks display, showing that quasars can also be used as standard timekeepers for the primordial universe. Please like and subscribe.